MPLS TE setup and hold priority. In this video, I'm going to talk about the MPLS TE setup and hold priority. First, I'm going to talk about the setup priority, and after that, hold priority. What is the usage of these two type of priority and how we can configure them and how we can verify or troubleshoot the setup and hold priority. Let me to talk about first setup priority before starting to talking about these two type of priority and also first setup priority. Let me to say that in MPLS traffic engineering, we can configure priority setup or hold priority, okay? And the priority, okay, is the preference. I will talk about that, but let me to say that in a TE, we have 8 levels of the priority between 0 to 7. For example, 0, 1, 2, 3, 4, 5, 6, and then 7. This means that we have 8 levels of the priority. The values that can be configured for both priorities, means setup and hold priority, are this value, okay? With 0 indicating the highest priority, okay? This means that 0's priority is higher than 1, then 2, after that 3, 4, 5, 6, and 7. And 7 has the lowest priority. 0 is the highest priority. Let me to write here. 0, okay, highest priority, and then 7, for example, lowest priority, okay? Now we can start to talk about the first setup priority. We can use one simple example for better understanding the setup priority. For example, we have R1 connected to router 2, connected to router 3, and after that connected to router 4. We are configuring one tunnel 0 interface, okay? And this tunnel interface destination is the router 4, and assume that here we have 1 megabit per second of bandwidth between the router 1 and router 2, and also between router 2 and router 3, and finally between router 3 and router 4. And because the tunnel 0's requirement is 1 megabit per second of bandwidth, these tunnels should come up, you know it, okay? And this is the normal behavior of the a traffic engineering tunnel, okay? And let me to say that every and each tunnel in the traffic engineering has a priority, setup priority and hold priority, but now I'm going to talk about only setup priority. And maybe you remember that when we configured the priorities, the tunnels in the traffic engineering scenarios before than this video, we saw that we have a command in the, for example, tunnel interface, and I said that I will talk about that in future videos. And that tunnel include the priority about the setup and also hold. This is the tunnel we saw but we didn't talk about that. Tunnel MPLS traffic engineering priority setup hold. By default, each tunnel has a priority of the setup priority of 7, SP or setup priority. Let me to use the SP instead of the setup priority. Maybe it's easier. Setup priority or for example, SP, setup priority, okay? The default value of the setup priority is 7 by default, okay? After that, now we consumed all of the bandwidth of this link, okay, this pass. Assume that we are configuring the next tunnel, for example, tunnel 1, and the tunnel 1's requirement is 500, for example, kilobit per second. Okay, and you know that the default priority of of every tunnel, the default setup priority is 7. Because of that, this tunnel should not come up. Why? Because we have same priority, same setup priority, and the first tunnel now comes up, and because of that, the tunnel 1 cannot be established between the router 1 and from router 1 to router 4. Why? Because we don't have enough bandwidth for the next tunnel. If you first configure the tunnel 0 comes up, okay, and tunnel 1 does not come up. But if you configure first tunnel 1, the tunnel 1 should come up and tunnel 0 doesn't come up. And this is for example, race condition. Race condition means with the order of the configuration or with the order of the, for example, enabling the tunnels with no shutdown command, the result can be changed, and this is not a good condition. Assume that we are using the tunnel 0, for example, for data transportation, and also tunnel 1 for the voice transportation. Okay, this is the voice. You know that voice is and needs more quality of service, and because of that we give the priority to voice. But because we first configure tunnel 0, now data can pass from the R1 to R4 with this tunnel, and the voice should be dropped. Okay, I will talk about the detail of the setup priority and also hold priority, but for now we can understand that the setup priority is the priority that we can use it for giving the preference to some tunnels over other tunnels. Okay, I will talk about the detail. Assume that we configure the both tunnels in one time. Okay, tunnel 0 and tunnel 1, and the setup priority of both of them are same, and the result may be in one time tunnel 0 first comes up and tunnel 1 doesn't come up, and in another time the reverse. Okay, but if you configure the setup priority for example 6 for the tunnel 1, and both of these tunnels establishing in exactly one time, first tunnel 1 can come up because it has higher preference and higher priority. Higher priority means lower value, okay, of the priority, and because of that the voice tunnel can be established and the data tunnel can be passed from another for example routers in the scenario. Okay, and because of that the setup priority indicate how important the tunnel is to preempt the other tunnels. But we can better understand the setup priority after talking about the hold priority. As I mentioned before, we have two value, setup priority and also a hold priority. Let me to use the HP instead of the hold priority. One interesting thing is that by default setup priority is 7 for every tunnel, and hold priority exactly same as the setup priority. This means that when you are configuring the tunnel and you don't configure the setup and hold priority, the SP or setup priority is 7, and also HP or hold priority is 7 for both tunnels. Okay, but first we need to understand what is the hold priority. As I mentioned before, the setup priority only is the priority when we are setuping the tunnels. Okay, and after that, after the first initiating for example time, after the establishment of the tunnel, we have another priority for the tunnel, hold priority. This means that assume that we don't have tunnel 1, okay, and we have only tunnel 0. Okay, when the tunnel 0 established with setup priority of 7, this is the hold priority that should take the priority of this tunnel. For example, when we have a setup priority of 7 and hold priority of 7 and the tunnel 0 established, the setup priority is not important. The HP or hold priority is important. This means that if the tunnel 1 tries to establish, the setup priority of tunnel 1 should be compared with the hold priority of the tunnel 0. The holding priority indicate how much the weight of the tunnel is to hold on its reservation on the link. Okay, this is the priority after establishing the for example tunnel. A tunnel that has a lower for example setup priority, okay, then the holding priority of a second tunnel can preempt that second tunnel. For example, this means that when we have tunnel 1 and when we are configuring the setup priority of 6, this setup priority should be compared with the hold priority of the established tunnel. And because now the tunnel 1's setup priority is less than the hold priority of the tunnel 0, this tunnel can preempt the tunnel 0 and can use this pass. We can configure these two priority with the command tunnel MPLS traffic engineering priority setup and hold. I will configure it, but let me to give you some examples about how we can configure the setup priority and hold priority. In most cases, we need to configure the setup priority and hold priority for example with some value near to each other. For example, we can configure both values less or more than other tunnels. Okay, let me to give you some examples. Assume that we are configuring the tunnel 0 with the setup priority of the, for example, 2 and the hold priority of 7. This is not a good choice. I will talk about that. But